Okay, right. Let me start the class. Right. Huh. Today we are going to discuss the topic of typecasting and control statements. First, we'll go with the typecasting. Okay. First, what will be the typecasting means? Right. The will be the day 6. Go to the new. In the new, I am creating one class for the typecasting examples. Yeah, we have the two types of typecasting. Typecasting categorized into two types. One was the implicit typecasting, another one was the explicit typecasting. It means first typecasting means you are converting one data type to the another data type. The way you are converting one data type to the other data type, we will call it as typecasting. In the typecasting also we have the two types. One was the implicit, another one was the explicit. Implicit means your JVM or your Java compiler convert the one data type to the another data type by your compiler, then it will called as a implicit typecasting. It was converting one data type, that is also from a low preference data type to high preference data type. One data type which is of low preferred to other high preferred. That means suppose normally low preferred means you have a short, right? Short will be converted to the normally. Suppose byte was converted to the short will be converted to the int, int can be converted to the float, right? And it will be converted to the long or double, right? Like this way, from small data type size to the higher data type size. Why? Because byte is the only one byte, short will be the 2 bytes, so 1 byte will be converted to the, but short cannot be converted to the byte in a implicit way. In a implicit way, which is was the highest preferred cannot to the lower, but lower one will be converted to the higher one by your Java compiler implicitly, by JVM, simply JVM. Okay, by JVM. And the next one will be the explicit typecasting. First we'll see the implicit typecasting and later we'll discuss the explicit. Suppose you have an integer value of int a equals to 10. Okay, int a equals to 10 and int b equals to, okay, float b equals to 2. Okay, suppose if I perform sys out of a plus b, then my result will be, 12.0. My result will be 12.0. Why? Because it is a data type of integer and it is a data type of float. Then result is also converted to the float only. Okay. Then result is also converted to the float only. It is you are not converted, but your compiler will convert it implicitly without knowing any knowledge to you. It is a implicit typecasting. Implicit typecasting means the conversion will be done by your compiler from lowest data type to or low preference data type to the high preference data type. Okay, right? Normal likewise, you can convert to the anything. Suppose we'll do one thing. Like this, you can convert. Suppose if you want the result of the final, if you want the result of the final to be in the integer itself, not in the float. Okay, you want the result is also in a integer, not in a float. Then what can you do is a explicit typecasting. That means you are you are forcefully converting one data type to the other data type. You are forcefully, or the programmer, you means programmer forcefully converting one data type to the other data type. That means suppose byte can be converted to the short, but short cannot be byte, right? That one in a reverse way. Suppose you want to convert it from double to integer or float to integer. Okay, or character to integer. Okay, that means explicitly you are converting the data type. That was explicit typecasting. Okay, in the explicit typecasting, let me see. Suppose int b equals to 3, right? What is the, if you perform a by b, what is the result? 3.33, right? Suppose in a normal division we can compare. Quotient will be the quotient is 3 and remainder is 1, right? For finding of the remainder we have a modulus operation, right? But for finding the quotient, how can we find, right? Quotient means 3. Then how can I find it? Is always the quotient be the integer, right? Suppose int q is my quotient equals to int of, normally typecasting, in which data type you have to typecast, you have to mention here. In this data type you have to typecast, you have to mention here of okay, this is the value you have to convert and this is the data type you are converting. Okay, this is explicitly or normally it will normally it will gives your 3.33, but you wanted the quotient value, so you are typecasting it and store it in a integer value. Okay, right? Or set, right? Sys out of quotient is q, right? Right, quotient will be the 3. Okay, suppose when someone asks to find the quotient and remainder values of a number, okay, of a number, then you have to, for finding of the remainder, modulus operator you have to use, and for finding of the quotient you have to use the typecasting of the division. Okay, when you are on the typecasting, always if 3.7 is there, then it will convert it to the 3 lowest lower bound integer, it will has to convert. Okay, this is normally explicit typecasting and the implicit typecasting. It can be helps you a lot when you are dealing with the mathematical, when you are dealing the mathematical related problems and all. Suppose there is a query to find the how many digits in a number, okay, or sum of the digits in a number. Okay, we will do that in a while loop, then you can understand, right? Suppose I have a number, I have a number of 2345. 2345 is my number. I want to sum the 2 plus 3 plus 4 plus 5, but I have to do it in a for every number in a programmatic way. How can I do that is suppose first if I perform 2 3 4 5 modulus of 10, what will be my result? It will be 5. The remainder will be 5. When you are performing any number with the modulus division of 10, it will returns the last digit. Okay, then what will be the quotient if you perform division operation to that? 2345 by 10, what will be the quotient? It will be 235, right? Then now 235 modulus 10, what was the result? Sorry, 234, right? 234, 234, 234 modulus 10, then the result will be 4, right? And after that 234 floor division, floor division means normal division 10 and typecasting to the quotient, then result will be 23. Again 23 modulus 10, my result will be 3, right? And 23 by 10, then quotient will be 2. Then after that 2 modulus 10, remainder will be 2, and the quotient will be 0. Like this till my number quotient will be the 0, I have to run a loop and I have to sum 5 plus 4 plus 3 plus 2. This is the way in the while loop we'll discuss it. Okay, normally this is the way the typecasting helps you. If without the typecasting concept you can't understand how the quotient will come. In a Python language there will be a floor division to find the quotient, but in the Java there is no floor division, so we have to typecast it. Okay, like the way. Next we'll go with the control statements. Okay, this is all about the typecasting. In the typecasting we have the two types, one was the implicit and another was the explicit. Implicit means your Java compiler independently can do that without knowing of your information, and explicit means forcefully the programmer or the user who was converting one highest data type to the lower one, or the lower one to the highest one. Okay, that's the suppose in a case someone give a someone give the one char ch equals to a, he wants to find the ASCII value for that character, ASCII value for that character, int ASCII. Then how can you find the ASCII value for a character? By using the typecasting. ASCII value is in the integer, but here you have to use okay. Then now you can print sysout of ASCII. Sysout of ASCII. Suppose in the reverse case, you have the ASCII number, but you have to convert it to the character. Then in the reverse way, int or char ch1 equals to, I think ASCII number for the A is 97 maybe. Char of 67. Okay, here I go with the 97. I think 97 is a small a. You see, 65 is capital A. I think 13, 97. Okay, I am not printing this ch1. If I print that ch1, it will represent that sysout of ch1. It will print small a. Capital will start from 65. Small a is from 97. Okay. This is the typecasting. Remember the concept. While because when you are go with the problems and the execution, then typecasting helps you. Suppose someone said you have to performing on the ASCII numbers based on that. Okay. Then those cases you have to know this, right? How to convert a character to the ASCII and ASCII to the character. Okay. Right. Okay. Next one. Next we'll go with the conditional statements or the control flow statements. Okay. Conditional statements or control flow statements. Control flow. Okay. Right. Control flow statements is which controls your the flow of an execution, which decides the flow of the execution. In this, the first type, control flow statements helps to decide the flow of execution. Right. In the type 1, the type 1 is conditional statement or a decision statement or selection statement. Selection statements. Okay, that means you have to execute a particular block of code based on the condition, selection statements or condition statement. Selection statements or condition statements. In that also you have a types. First one will be the if, second one will be the if else, third one was if else later, fourth one was switch case, fourth one was switch case. Okay, these are the based on a condition you have to execute something. If else if later. Okay, and also nested if is also there. Nested if. In the switch case, if else, we'll see the syntax and go with that. In the first case, suppose you want to check a number is an even. Suppose you want to check a number is an even. If the number is even, you have to print even, or if number is odd, you have to print the number is odd. Right? For that, what I have to do is all the things I have to do with the reading a number. Scanner SC equals to new scanner of I have to import that scanner class. Import java.util dot star. I'll go with the star. New scanner of it was accept one thing system dot in, right? Suppose I want to store the one value, right? Int a equals to sc dot next int, right? And what we have to do here is sysout enter a number. Okay, and you have to check the number is even or not even. Okay, if that number is an even, how can you check a number is an even? The number will be that divisible by exactly divisible by 0, right? A is my number, a mod 2 is 0 or not, I have to compare. Equals to 0. This statement proves this statement true, then it will execute this block of statement. What you can write under this block is these statements will execute only this condition true only. Suppose in that case what you have to do, sysout of uh, a is even. Okay, is even, a is even. Once I'll run this, I have to enter here number. Okay, suppose I'll enter the number of 12. 12 is an even. Suppose if I again I'll run this, I'll enter the odd number. If I enter the odd number, that means if I enter the odd number, this condition will be false, right? At the time of condition false, I'm not mention anything what it has to execute. Okay, I'm not mention here anything what it has to execute. That's the purpose we have a else block. What that else block will do is if the if condition will be true, that means if condition was false, then it has to be execute that else. If the if condition is true, not execute else block of a is odd. If I enter the odd number, then else block will execute, not if block. 23 is odd. Okay, from this what you have to understand, if block will be execute based on a condition true or false. If the condition true, if block will execute. If you have else block, then it will execute the else block. If condition is not true, then else block will execute, right? This is normal if and if else. The syntax is like if is the keyword, syntax is if is the keyword, this is the condition, and this is the block of statements. Okay, and the syntax will be here. If condition condition and the block of statements. You can write n number of statements under this block, but that block of statements has to be execute only this condition true only. Okay, that is the if syntax. And then else means else, if the condition will false, then it will come to the else block of statements. Okay, this is the normal syntax. And after that, in the if also, you can go with the nested if. Suppose I have a number, I want to check that number is greater greater than 10. Okay, I want to check a number is greater than 10, the number is greater than 5, the number is greater than 6. Okay, or else simple program to that. The same way I can read the another number, int b equals to sc dot same way int c equals to sc dot next int. Same way enter a number, control c, what I have to do here, I have to find the greatest among the three. Okay, greatest among the three. Suppose how can you say a is greater than b, and suppose you want to say a is greater among the three, a is has to be greater than b, and also a is has to be greater than c, then c, right? Then what you can say here, a is greater among three, right? Suppose you want to find else, that means by this one statement you can conclude the only one thing. The thing is only a is greater than among the three or not, but you want to find which one is greater. Suppose b is greater or c is greater, then you have a statement of else if. That means you have the n number of conditions. Suppose one condition fails, it has to, suppose this condition is fails, that means among the b and c, one will be the greater, right? Then what I have to check here is b greater than c, right? How can you say b is greater among the three? B is greater than a and b is greater than c, right? But only I am writing the b greater than c. Why? Because this condition fails means this a greater than b and a greater than c condition fails means a is not greater among the three, right? Then greater lies between b and c, right? So I have to check which one is greater, b or c, right? Then I can conclude this out. B is greater among three, right? The same way If the both statements not work means C is greater, right? If the above three conditions fails means C is greater, right? Else if condition only execute only if condition is fails. Okay, this else will be execute only else if condition fails. You have to observe the hierarchy. This will be execute only if condition will fails only, or else it will not check these statements also. Okay, or else it will not check the statement. Suppose in place of else if I place the if, in place of else if I place the if, this if is different, this if is different, this condition true or false, it will not an issue, but it will be execute. Okay, that is the difference between you are writing ifs parallelly and if else if later. Else if later if you are used, in that case, in that case only above if condition or above else if condition only fails only, current else if condition will be running, or else it will be false. If you write n number of else ifs, one after failing only another will be checked. Okay, suppose the simple example is you have a marks, you have a n number of marks, or one single marks, it has to be greater than 90, greater than 80, greater than 70, like that way, right? This is the normal if elif ladder. I'll enter 10, 20, 30. It has to print 30 is greater, right? 30 is greater among three, that means else block will execute. Now my query is, I want to display greatest, second greatest and third greatest. Among the three, I want to display second greatest and the third greatest. You are doing the 50% of task here. By this you can achieve the which is the highest greater, right? Here I can place first greater among the three, right? First greater among the three. If A is the first greater means second greater will lies between B and C, right? So you can check if B greater than C, what I have to print. If B greater than C means B is the second greater, right? B is the second greater, B is the second greater among three, and C is the third greater, right? C is third greater. C is third greater. If this condition fails means C is greater, right? So I can simply copy it and paste this here. C is second greater and B is third greater among the three, right? This is the nested if. That means you are writing one if inside the other if condition. If you are writing one if condition inside the other if, then it will called as a nested if. Okay, then simply I can write this for the other two also. If B greater than C, right? Then you have to change A. Why? Because the greatest will be in between first greater. Here A will be the second greater, C will be the third greater, C will be the second greater, A will be the third greater, right? And for the same, right? Here you have to check in between A and B. A is the second greater, B is the third greater, right? And also A is the second greater, sorry, B is the second greater, A is the third greater, right? Now I can run this. Enter a number. Okay, I simply go with the 10, 20, 30. It will 30 first grader, 20 second grader, 10 third grader. That means this one else block will execute. The same way, I'll go with the 10, 30, 20, right? The same output, but the input difference is else if block will be execute, right? Right. This is the way nested if and the else if later. Okay. And next we will go with the switch statements, switch case statements. In the else if only we can run another one. You can try with. Right. Mm. Next we'll go with the an example on else if ladder. That was on marks you have to calculate the grade. Okay. The simple thing will be the for the better understanding of the multiple else ifs. That's the fact. Okay. Here I am reading one number. I have to calculate the grade for that number. Normally, if the A is greater than or equals to 90, my grade will be the 6 out of what will be my grade? Grade A, right? The same way. Else if you have to write the condition. Else if A greater than or equals to 80, 6 out of grade B, right? The same way. Else if of A greater than or equals to 70, then grade C, okay, or else 6 out of grade fail, okay. Okay, right. If I enter a mark of 95, then it will print grade A. If I enter the mark of 85, it will print grade B. Like that it will do, right? I'll go with the 75. Grade C will print, right? In place of else if, I'll go with the L if only. Okay. Then if I enter the 95, which statements it has to be print? It will print this statement also, and this statement also, and it will not print this statement. Okay. Suppose if I enter the 75, then this statement and this statement. If I enter the 95, why it has to print these three also? Because I am writing here if condition. That means it will check with the 90, and also it will check with 80, and also it will check with 70. When you are writing the else if, it will fails only, it will check else if condition. If it was true, it never checks that else if. Because of that, the condition true also, it will not, if we at 95, normally 95 is greater than 80 also. So it has to execute this block. But if you are using the else if, above if condition is true, it never execute the below if condition. Okay. Suppose if I run this and I give the 95, then it will print grade A, grade B, grade C. I hope. This else block only for this pair of this if. If I go with the 95, grade A, grade B, grade C. Why this else block will not execute means this else block is paired with the only this if. This if condition will be run, so this else will not run. Okay. This is you have to understand the difference between if and parallel if and else if ladder. Else if ladder only the condition will execute, above if condition fails only, right? if if it is fails only, this if condition will be checking. This will fails only, this will be check. This will fails only, this will be check. Okay. You have to understand the difference between normal if you are writing the parallel and this else if you are writing the parallel. Okay, right. This is with the else if ladder and the nested if. Next we'll go with the switch case. Right. Switch case is also like a simply one else if ladder, but the difference is switch case will execute based on the single expression cases. Normal example, suppose you are reading a value of the thing. First you can see the syntax, how the switch case can write. Normally switch is the keyword you have to write, and here you have to write one expression. Based on this expression, the cases will be selected, case and the expression value. Okay, value, and also block of statements for the case block of statements. And for every case must you have to write the break. If you are not mentioning the break, it will execute the all cases. Okay, break is the one looping control statement. Okay, break is one looping control statement, you have to understand. Like this you have to write multiple cases, and one will be the default. If above cases are not execute, default will be execute. Okay, this is the normal syntax, we'll go with that. Switch off. Suppose I want to read a value. Scanner sc equals to new scanner of system.in, right? Int a equals to sc dot next int, or I can go with the character na? Int char equals to sc dot next line. Okay, okay. Or else simply I can go with the characters. How can you define? Okay, sc dot next int. Normally suppose if I enter the value of 1, I can print the Sunday. Like this you have to based on a values 0 1 2 3 4 5 6 7, you have to print some Sunday Monday based on the days number, you have to print the day, right? Normal simple example how the switch case will helps, right? Case, suppose my case is 1, I have to print suppose I'll go with the Monday for 1. Okay, here you have to pass the expression value. It will be the A, it will be the C, or any expression. Okay, this expression based on the expression result. Suppose here you getting the 1, this case 1 will be executed. Suppose if I am writing here and I have to mention the break. Okay, if I am not mentioning the break, it will execute all the cases. Sys out of Tuesday, case 3, sys out of Wednesday, break, and case 4, Thursday, break, and default one. Why default one helps you is if any case you are fine with the value, then default will be the print. Okay, default case is executed. I'll run this. I have to enter a value. Suppose first I'll go with the okay. I have to enter a value. My value will be the 5. I don't have any case of 5, so it will execute the default one. Default case executed. Okay, I'll run this again. If the case will find only, it will execute it, or else it will break. Suppose if I'm not mentioning any break, I'll go with the 3. Okay. Suppose based on some expression result, you have to execute some particular case of block. Okay, then switch case will help to you. Simply like a LC ladder, but the difference is only based on a single expression value, it has to be executed the multiple cases. Okay, it is one option of a conditional statement. Okay, right. Hmm. Yeah, suppose normally you have the values of hmm, uh, suppose I have the cases of weekdays from 0 to 6 or 1 to 7, right? Other than that, I have to enter when I am entering, then the default case will be executed. Okay, if you are not giving the default case, okay, suppose if I am not mentioning any default case here, I'll go with the 8. It will not print anything, or else it will not throw any error also. Why? Because it will not find any case. If the matching case is fine, it will execute. If the matching case is not fine, it will not execute the default case. That means it will execute the default case. If matching case expression will not found, then it will execute the default one. If fine, it will execute that block of code. You can write n number of statements under this block. Not at all an issue. Okay, from colon to break, all are taken as one single block for the every case. Okay, right. These are end up with the decision making and the selection statements. We have to move for the looping and the break and control, this iterative control statements. We'll discuss that looping statements tomorrow. Why? Because if you start also, it will not complete. So for that, okay, right.